Hello, everyone. Welcome back. First, you have a quiz today. There is a new quiz that is going to open by the end of the lecture. You have the full day to complete the quiz. It's going to be the last quiz. So that is going to make 6 quizzes, all of them together, 25% of your grade. So each quiz is a little bit less than 5%. So your last quiz, probably today, you have the full day, is 30 minutes, all about patterns. So probably you would like to review at least the slides or the videos if you want regarding design patterns and architectural patterns. Both is one quiz about both of them. Some class diagrams that you need to identify, some source code, some questions about which is the class diagram that correspond to the source code. The goal for that is give you an idea of questions that are going to be in your final exam. Remember, final exam next week. So it's just the first step to review your knowledge and if you are ready for the final. Half an hour, the last quiz. So don't forget. For today, one of our last topics, we have been doing these requirements to the source code with the design in the middle. The last thing that we need to check is the quality of our product, the quality of the software, the quality of the design. I want to do 2 things today. Number one, the quality of the product, the quality of the source code is something that you already know. It's something that you review in 360. The only thing that I need to be sure is that you remember those concepts, the metrics for the software. And the second thing is I need to add metrics that apply not to the source code, but to the design. You can measure the quality of your software, your product, reviewing your diagrams, your design. So I want to introduce the metrics that work with the design before I am going to do a review of the metrics that you already know that work with the software. So metrics. The goal of the metrics is to measure the quality. The thing that we already do was to move all this way to a solution. What can we measure in the solution? Well, we can measure for sure the source code, but also we can measure things in the diagrams. What we can measure in the diagrams? The connections. That is going to be the most important part. If you think about your class diagram, all those lines, doesn't matter if they have diamonds or triangles or arrowheads or whatever, we can get numbers from them, and those numbers represent the quality of the product that you are creating. So quickly reviewing these concepts. For the metrics, 3 metrics that you already know, and we're going to add another one. The 3 that you already know is you can measure size, you can measure understandability, and you can measure complexity. I am talking about things that you can measure in the source code. We're going to add here new ones for the design. For the source code, use a quick review, things that you know. The size. In order to measure the size, you have lines of code, E-lines of code, logic lines of code. I need to be sure that you remember those 3. For the understandability, comments and white spaces. For the complexity, one particular metric, cyclomatic complexity. And I need to be sure that you remember the meaning of that and that you can calculate that one if I give you a particular source code. It's something that you're going to do in your exam. Calculate the metrics for a particular source code. So talking about this, lines of code, cyclomatic complexity, and understandability. Quickly, because again, I assume you know them. So size. Number 1, lines of code. Lines of code, just like that, these represent every single line in your files. How many lines your files have. It doesn't matter what is the line. If you have a curly bracket alone, that is 1 line, period. If you have a complex instruction here, that is 1 line. And this is one, and this is one, doesn't matter the complexity or the number of characters or whatever. You are just counting the lines of code. This one should be easy. Effective lines of code. This one, the effective is all the previous ones, all the lines of code, except these ones. You didn't count comments, empty lines, or brackets or parentheses that are alone. Makes sense, right? It's like, if you're going to tell me that you have public something like that, how many lines of code? How many effective lines of code? Question in your exam, can you calculate the numbers? I think it's kind of easy. Yeah. So 1, 2, 3, 4. You mentioned 4. Hopefully we agree 4 here. Effective, well, according with the definition, this is not effective, this is not effective, this is not effective. Okay. All the lines except the one that we mentioned before. Comments, empty lines, brackets alone. Easy. Logic lines of code. Logic lines of code. Only the lines that end with a semicolon. Why? Because those are the ones that have instructions. So only the ones that ends with a semicolon. In my previous example, 0. There is no line with semicolon. There was no instruction in the example that I put here. Usually, it's not a rule, but lines of code are going to be more than the effective lines of code. And the effective lines of code are going to be more than the logic lines of code, because we're being more specific in things that we're counting. So everything except the things that I put here in red, and only the ones that have semicolons. Those are the 3 metrics that we have to measure the size of the software. Again, you need the source code, and then you can count this. Now, a particular exception, a particular case that hopefully you remember is when you have a for loop. When you have a for loop, something that you're going to have is 2 semicolons inside of the parentheses. So even though you have 2 semicolons, that one is going to count like 1 effective line of code. It's called like 1. Why? Well, because the instruction needs 2 semicolons, but really the important thing that is happening there is 1 for loop, is 1 instruction that needs 2 semicolons for a particular thing. So that particular case, even though you have 2 semicolons, that count for 1. So it's not about counting how many semicolons do we have, because that's a specific case. Other than that, just counting the semicolons. So something like this, hopefully you agree with me. Source code, lines of code, effective lines of code, logic lines of code, only 1 semicolon, only 1 line, all the lines that we have here. And these guys are here, but not here, are here, but not here. Question in your exam, you have a source code like this, maybe bigger, and use how many of this, and this. Done, easy. Something that you already did before. You reviewed this in 360, so nothing new here. Just for you to remember. Logic lines of code, effective lines of code, and lines of code. Yeah, that is a very good question. What happens if for any reason you have something like this. It's like, well, this one, lines of code. I'm talking about just the rectangle. If you think about lines of code, that one is only one, because we do not have any particular limitations about what is a line of code. That one is one line in the file, period. If we think about effective lines of code, that one is one, because again, it's going to count like one. It's not a comment, it's not a white space, it's not a parenthesis or a curly bracket alone, so it's one line, one. For the logic, we're counting semicolons, so we have two semicolons. Is a for loop? No, it's not a for loop. So logic lines of code in that scenario, two. One of the few cases in which you're going to have something different than this. And the reason is, well, because the programmer is doing something that is not exactly the best thing to do, two instructions in the same line. But your metrics are going to reflect that. So one, two instructions. Again, the logic, only those lines that end with a semicolon. So only in the line ends with a semicolon, that is a logic line. Logic, semicolon. The idea is the logic lines of code are instructions. And you know, instructions end with the semicolon. I am talking about Java, and probably did work also with C, C++. Obviously, how to calculate lines of code or effective lines of code or logic lines of code in a different language is going to be different, right? Depending what is the delimited that you use to end instructions. That is the one that is going to replace the semicolon. For Java, C, C++, the semicolon is the one that we use to end instructions. So with the logic lines of code, we're counting how many instructions do we have. Notice that for the logic, we are not counting the condition. We are not counting, in my example, the signature of the method, the bracket. We don't care. It's how many instructions do we have, logic lines of code. For the effective, it's like we are counting everything except, as we mentioned, these cases. The comment, which makes sense, the empty lines make sense, and all these empty standalone brackets and parentheses, just because, you know, some people have this style, opening and closing something in one empty line. So basically the effective lines of code, what they are going to do is to do not count those. So exceptions, and here we're searching for the semicolon. That is the difference between the effective and the logic. And for the lines of code, everything is one line. It's just how many lines do we have in the file without caring about what is the content. It's just how many lines, period, lines of code. Good? Okay, this one are the easy ones. Now, moving forward. Something that you should ask is how many lines of code are okay inside of a method. Usually, it is not mandatory. There is no magical numbers, but usually this is the table. These are the thresholds that you need to consider. If you have a method, if your method have around 50, that is fine. The recommendation always is less than 50. So 20 is a very good number, 25. Again, no magic numbers, just an idea. 20 lines is kind of a paragraph. It could be read easily. It's going to fit perfectly in a page if you print it. So 20, 25, 30 could be okay. It's a page. It's something that you can read quickly. 50 is still okay. It's going to be a small font, one page still. Worst case scenario, 2 pages. Is still something that you can handle. When you move beyond 100, critical point is something that usually is asking for refactoring. It's asking for, you know what, this method can be split in 2 methods. Think about it. But critical wrong. Just remember the 100. Always your methods below 100, mandatory. Below 50 is good. Above 100, and if you reach 200, that is awful. So again, there is no magic numbers, but usually you're going to notice this is the average. Lines of code. I am talking about this, lines of code. I am talking about every single line counting, 100. Obviously, effective lines of code and logic lines of code should be lower than this. You do not want 100 instructions, things that end in a semicolon inside of one method. So the recommendation. That is size. Talking about understandability. Understandability, two things. Some source code is easy to understand according with these guys because two things. Number one, how many comments do you have in your source code? How many comments? We have talked about this before. Comments are not mandatory. The best source code is the source code that you can understand without comments. However, when you need comments, well, it's because it's something complex there in the code and something that you cannot explain just with the names of your variables and the instructions there, and you need to add a comment. Well, something that we measure is how many comments do you have in your source code. Usually, the number of comments is talking about the complexity of the software, because if the software have comments, it's because the developer, you, consider that comments are needed. This is what we are going to measure. How many lines of comments do you have in comparison with the total lines that you have in the software? So if you have 3 lines of comments and you have a class that have 100 lines of code, well, you do the math, 3 of those lines are comments, 100 lines in total. So the number is small. All these numbers are metrics. Which number is good or bad usually depend on the context, depend on someone that understands what is the problem that you are solving. This one, if I have a number that is small, basically what I know is that I have a few comments there. That is good or not, depending on the complexity of the software that we are developing. If we know that the software is so small, so easy, like a hello world, and you have something like 50% of lines comments, it's like, I know that the software is easy and half of the file is comments, this is wrong. On the opposite, you are developing something very, very complex, machine learning algorithm or something, and you have a comment percentage that is below 0.0001. It's like, well, I know that it's complex, and I would like to have more information, but I do not have enough information because you are telling me that I have 0.0001 comment per line of code. Depend on the context. The numbers are used, measures that they are going to have some meaning compared with something else. If you read a number and that number represents the age of a person, that number is high or low, depending. Is the age of a professor or is the age of a student? High or low, everything depends on the context, right? So the percentage of lines of code. Similar way, white spaces. Usually you do not do this manually. There are software that give you these numbers, and we're going to talk about it. You can take a file, and you can put your file in a piece of software. The piece of software is going to count literally how many white spaces like this one or this one or this one. It could be an enter, it could be a tab, it could be a white space or 2 white spaces together, whatever. Basically, we're going to count how many white spaces do we have in comparison with the total number of characters that we have in the file. All the characters, including the white spaces and others. All the characters in relationship with how many of them are white spaces. This is going to give us a number, a percentage. And you remember, it's a good idea to put some format in your programs, some tabs at the beginning, some white spaces, indentation, and so on. And every time that you do that, you are adding numbers to this, to the number of white spaces. It doesn't matter if you put a tab or you put several white spaces. The number is going to be higher or lower depending on your style. But the point is, somehow, the relationship between all the characters in your file and how many characters are white spaces, that percentage is going to tell you something. Compared with the context, you are going to know that you have a program with a lot of white spaces, something that is close to 70%, and you're going to notice like, okay, this is a program that is so easy, but the developer used add spaces to maybe present something that is bigger, even though nothing important is happening there. Or the opposite is 20 lines, but comparing the spaces is everything is crammed in a few lines. Numbers. Understandability. How many comments do we have? How many white spaces do we have? White spaces help to understand stability, help to read the document. 2 metrics for that. Easy to calculate. Complexity. Complexity, one metric, one important metric that hopefully you remember, cyclomatic complexity. Help me, what is cyclomatic complexity? Very good question. Usually you do not calculate that. Usually those are numbers that some tools give you. The only thing that I want, the only reason because we mentioned is for you to be aware what is the meaning of those percentages. That's it. But usually the important metric, lines of code and cyclomatic complexity. Those two are the important, the other are just complementary. Yes, cyclomatic complexity, the number of independent paths, yes. Calculation of cyclomatic complexity. If I show you a method, what do you do to calculate cyclomatic complexity? What do we do to know how many paths do we have in a particular method? Yeah. Option number one, you can draw the control flow. Yeah, you can do all of that. In 360, maybe you learn about it, the control flow and the paths and so on. An easy way to calculate things. You have this source code. You can create the graph, and in the graph, you can do, as you mentioned, calculate the number of nodes and the number of connections and so on. If you remember, those are the paths. Cyclomatic complexity of this thing here can be calculated in this way. And the cyclomatic complexity is 4 because the equation, blah, blah. Yeah, I am not going in that direction. This is something that you already know. This is something, the theoretical background that you know. I want to talk about the practical way. What could be the easy way to know that cyclomatic complexity of this is 4? Exactly. 1 plus how many conditions do we have? Can you quickly identify how many conditions are in this source code? And hopefully the answer is, yeah. I mean, there is a condition in the while, there is another condition in this while, and there is a condition in this if. The conditions are in the whiles, do whiles, if, and for's, right? Those are, I mean, all the loops and all the conditional statements that you know, those statements have a condition. You can quickly measure how many conditions do we have in a method. You quickly know that you have 3 conditions here. Add 1 to that, and that is the cyclomatic complexity of your method. Done. So yeah, you can go from the code to the graph, from the graph, apply the equation, and that is going to give you the cyclomatic complexity. Yes. Usually in the practice, it's easy to do the other. How many conditions plus 1 done, cyclomatic complexity. You can just count the conditions. That is fine. So cyclomatic complexity now. This cyclomatic complexity is 4. My question, there is a number, a limit regarding what is the cyclomatic complexity that is recommended for a method or not? And if so, which could be that limit? Cyclomatic complexity of a method should be below what? Do you think that this cyclomatic complexity 4 is complex? This is the source code, cyclomatic complexity 4. Complex? Yes or no? You can handle, right? It's like, it's not my best option to have 2 loops embedded and a condition inside, but it's something that you can handle. In fact, this is most of the search or short algorithms that you review. One loop inside of another, plus one if. It's not so hard to understand. Several data structures have this. Several source code that you create in 110 is this. Cyclomatic complexity 4 is not so bad. Limits. Usually, 1 to 10 is fine. 10 to 20, medium complex. 20 to 40, complex. More than 40, sad face. What is the meaning of this? That having 9 conditions in one method, remember, you always add plus 1. So if you want to do the opposite, cyclomatic complexity 10 is talking about 9 conditions. 9 conditions is still something that you can handle. Human brain, you can keep in your mind usually 7 things. So 7 conditions, you can remember what is happening with 7 different paths. No problem. 8, 9, still okay. So we can handle this cyclomatic complexity 10. Why 10, not 8? It's easy to remember 10. So cyclomatic complexity 10 or lower, good. Twice that is going to be complex. More than that, twice the 20 is going to be very complex. Twice the 40 or beyond is going to be almost impossible to be tested. I am not going to talk about testing here, but you remember, all these different paths is something that you want to test. Remember the branching thing? Anyway. Yeah, this is a measure for each method. Very good question. We measure cyclomatic complexity for each of the methods. So each of the methods in a class is going to be measured like this. And what you do for your classes is to have an average cyclomatic complexity in the class. That basically is the average of the cyclomatic complexity of the methods inside of the class. Usually, it's going to be similar to my description before. When you have a method, and that method have 100 lines of code, maybe, and that method have a cyclomatic complexity of 50. Because somehow, more conditions usually is going to be more lines. So when you have a cyclomatic complexity high, that is more or less connected with a high number of lines of code. When you have something like this, the solution, the request for you as a developer, a good idea, if you want to think about that, is to create more than one method, to refactor that method in 2 or 3 or something. And with that, you can split the lines of code, and also the cyclomatic complexity is going to go down. One scenario is that you're going to split 50-50 25 conditions in one side, 25 conditions in other. So you are going to drop the complexity in 2. Now, remember, we reviewed this pattern for chain of responsibilities. And one of the things that the pattern do is, instead of having this very, very complex method with a lot of conditions, you create several classes, and each of the classes have one method that is taking care of one of the conditions in that big method. You are not only splitting the method in several methods, but also inserting those methods, several, not in one class, but in several classes. And well, that allows several people to work in the same problem. Different idea, but again, split. That is the request. Usually what happens is we start working in a solution, and that solution, even though it's a prototype or not, is going to move around here or even around here if you start working with the main and everything is there. But in some point, you are going to refactor. In some point, you are going to make improvements in your code. And the first thing that you're going to do for sure is to split in methods. And doing that, your metrics are going to improve. Again, the metrics are just numbers, and the numbers are telling you things about the quality of what you have. It's not good or bad by definition. It's just, this is the number for your problem. You think that these numbers are good or not? The age of a person. Who is this person? The number is too high or too low? Too high or too low for what? So cyclomatic complexity, conditions plus 1, and some recommendations. Now, if you have a software and I give you these metrics, what do you think about the software? Again, I am giving you the numbers without any context, but used for a generic project. If you read this, do you understand what these numbers represent? And hopefully the answer is yes. Second, this project is something that looks good or can be improved. And that is something that you can review with the numbers. The numbers that I put with the arrows in red, what can you infer from those numbers? What could be your recommendation for the team that is doing this project? The 4 metrics that I highlight. Well, answer in the comments in the chat. Remember, one of the things for the Agile methodology is that the members of the teams are people with high technical skills. So the assumption is that in every single sprint, we have people with good skills working, and every solution that you deliver is to the best of your knowledge. So the idea inside of Agile to use another sprint just for refactoring or just for fixing the quality of the code is not something that really exists. The assumption is that you're going to finish with the best solution possible. What is going to happen, and is there in the Agile manifesto, is you can insert in your backlog a request for fixing a bug. And a bug could be anything there, including something that you want to refactor meaning change. But again, it's not like I am going to use 2 or 3 sprints just to improve the quality of my code. The assumption is that the code have good quality in every sprint. There is always opportunity for improving more, but good technical skills is a request for the Agile team, right? Anyway, so what do you think about this? Something that hopefully you notice is how many lines per method, average. Something that you could notice is the cyclomatic complexity per method. I don't know if you can notice this, but something that maybe is happening because the difference between those numbers is that you could have in this project a few methods, maybe one or two, that is particularly complex. Did you notice? According with this, you have 24 methods. It's a good number in 3 classes, 3 files. We're talking about less than 10 methods per class, which is okay. But then when you review the average cyclomatic complexity, 1.5 is like, could be that several of the methods are cyclomatic complexity 1 just because it's the lowest value there, which could be that you have a lot of setters and getters, very simple methods. But then the maximum cyclomatic complexity is 6. So what happened in order to move from a 6, one value, to an average of 1.5? Basically, what you're noticing just with the numbers is you have a lot of methods with maybe a cyclomatic complexity 1, a lot. Just think about moving this 6 to 1.5. Without noticing the method, it's like several different methods that are doing nothing, and 1, maybe 2, that are doing the full work. It could be a good idea to go and check those methods and probably delete some methods here. Are you really using all these setters and getters? Or you just put setters and getters for all the variables, but not all of them need these public interfaces? Big question. 1 with cyclomatic complexity 6 is not so bad, could be okay. Anyway, is really only 1, or there are more? Something can be done here. 6 is not bad, but if you can have 2 methods with 3, it's better. How many lines of code per method? It's like 10, 20. Looks good. If this is a simple software, a simple piece of software, great. If this is a complex system, good, perfect. Things to review. Use with the numbers. Anyway, those are the numbers for source code, something that you already know, nothing complex. For testing yourself, something that I would recommend you is source code. Can you calculate the log, E-log, L-log, and cyclomatic complexity for this? Obviously, I am not going to ask you to calculate the percentage of white spaces. I am not going to ask you to count the white spaces, but maybe I ask you to calculate the percentage of comments, just because I put some comments here and here. So comments is something that you can calculate. Cyclomatic complexity, you can calculate it obviously per method, and or the average for the class, and lines of code. If I ask you to do this with this source code, can you do it? Any question about it? Good. You can do it. Okay, I am going to assume that if one can do it, one student can do it, all of you can do it. Practice, I am going to post these slides for you, so you could practice with these ones, and that is something that could be helpful for your exam. In the exam, basically, I am going to ask you for the number. You put the number, the computer grade correct or incorrect, so just be sure to do your numbers correctly. You can use white space during the exam, so if you need paper to do the numbers, you can have it. You know how to calculate the numbers. For the top, if we're talking about lines, the total number of lines should be 25, the total log. Everything is a line. So yeah, the top is 5 lines. The 5 lines for the comments. Not only 3. You count this and this also as part of the comments. The color help, right? So all of that, 5 lines are the comments. And calculating the comments, yes, you count 5. It's going to be 5 plus 9. So we have 9 lines with comments, 9 lines that are related with comments, and we have a total of 55. So you can calculate the percentage. 9 lines with comments, a total of 25. But the comments and the white spaces, they are including everything. So for the comments, we use the lines of code, not the effective of the logic. Use all the lines count. So 25. Good. Okay. So what about the cyclomatic complexity for this one? Use randomly. Cyclomatic complexity of the method M1. 2 or 3? 3. Okay. 2 conditions plus 1. Do not forget the plus 1. So 3. What is the lowest cyclomatic complexity that we can have in a method? The smallest value for cyclomatic complexity can be 0 or 1. A method like M1, print, high, something like that. Can we agree that that method is going to have cyclomatic complexity of 1? There is no conditions. 0 for conditions. 0 plus 1, 1. Good. So a common error in the exam, you cannot have cyclomatic complexity 0. We do not have conditions, is 1 because of the plus 1, right? Which makes sense. Remember, cyclomatic complexity is regarding the paths. So if you do not have conditions, you have one path, the line that connects the beginning with the end of the method. So 1. Good. So that is with the code. Another example that you can review, and well, lines of code, effective lines of code, logic lines of code, cyclomatic complexity for the different methods. That is something for you to practice. Any question, let me know. If you remember 360, these are the same slides that you had in 360, the same examples. So you already did this. If you take the class with me, if not, I am sharing with you the examples. Please review. Something like that could be in your exam. Be sure to understand these metrics. It's something that you already know. So I am not using a lot of time here. Next, that is the complexity for the source code. Now, what happens if I do not have the source code yet? What happens if I want to review the complexity in the blueprint, in the diagrams? So, to be clear, we do not have yet the source code. We haven't started programming, or maybe someone is programming, but we want to know how complex this is going to be. Or if we have a point that we need to do refactoring before I start programming. I am talking about structural complexity metrics, and just to connect this with the previous one that you know, structural complexity metrics, your input, the diagrams. I want to know if these two diagrams represent solutions for a particular software, for a particular system that I asked you to do. For instance, your assignment, the one that you're going to submit this week, or the one that you submit before. Probably I do not want to review your source code. The grader is the one reviewing your source code. Probably I want you to open your diagram, and I am going to find this diagram for one team and this diagram for the other team. The diagrams are going to be different in the same way that the source code is different, even though you are solving the same problem, but different people create different software, different source code, therefore different classes, different diagrams, different relationships even. I would like to know which one of these two solutions is better. Can we know which one is better? Can you guess, like, if these two represent a solution for the same problem and both solutions are combining and running, we assume that both are working. Which diagram, which code is better? A or B? We can guess. Which one do you like the most? Which one would you like to use if I share it with you and I ask you to modify or change something there, update? Which could be better for you to work with? the A or the B, and why? Some people, you can agree or not, but most of the people are going to tell me, I want this one. If both are solving the same problem, my first thought, the first thing that the people mention is, I prefer the A. And when you ask why, the reason is because the connections, there are fewer connections here. There are more lines here. And something that you remember now is every single one of those lines represent a call to a method, the creation of a local variable, the creation of a global variable. Each of those lines represents source code, relationships, collaborations. If you are telling me that both are solving the problem, and you're giving me the option to choose between one and the other, probably my first option is going to select that have fewer number of connections, just because that means that the source code maybe is going to be also smaller, at least easy to read. It could be true. Now, the tricky part is the number of connections is important. Yeah, the number is important. But you know what? It is more important the direction of the connection. It is more important to check if we have, for our classes, connections going in or connections going out. And here, we have a lot of connections going into that class. Here, we have several connections going out. We don't care about what is the type of the connection for the metrics. For the metric, the only thing that we're going to check is go in or go out. And just because we're using arrowheads, hopefully it is easy to notice what I am talking about going in and what I am talking about going out. So for instance, this one, the panel, how many connections going in? I don't care if those are inheritance or association, or even if there are diamonds, but it's easy to notice that you have for the J panel in the A, 5 connections going in. How many connections going out? 0. For the team A ghost, connection going in, 0. Connection going out, 2. 0 and 2. And so on. You can count for every single class that numbers going in, going out. So that have a name. Instability. Instability is the number that you calculate with this equation. The equation, the number of connections that go out divided by the total number of connections. The ones going in plus the ones going out. Instability. What is the value for instability of this J-panel class? Can you do the math? Something that you're going to do in your exam. Instability of the class J-panel. Well, according with the equation, is the number of going out divided by, oops, going out 0. So this is going to be 0 divided by 0 plus 5. Okay, I don't care about the 5. It's going to be 0. What about this team ghost? Instability for that one, well, is the number of going out divided by the number of going out plus the number of going in. Even though it's a 0 here, but it's for the in, the total for this one is going to be 1. Always, 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 you are going to have a number between 0 and 1. 0 represents that you have a lot of lines going in, most lines going in, right? all of them is going to be a 0, but if you have something going out, but most of them are going in, the value is going to be closest to 0. And the opposite is the other example. Most of the lines going out, you're going to have a number close to 1. If all of them are going out, you're going to have the 1. That is important. Why? Well, when you have a class and that class have this instability value 0 or 1 or something here, for a normal class, I am talking right now about classes, not interfaces, not abstract classes yet. I am going to include them later. But if you're talking about classes, just normal trivial classes, having instability 0 is something bad, sad. Remember, these are numbers. So the numbers are just telling information, and you are the ones that interpret that information. But in general, a value of 0 is something that is, well, let me change the idea, not sad, something that is going to be an issue, something that you should be worried about it. And number 1 is usually something that you can be happy about. Why? Let's go back to the example. 0, 0, worry. 1, happy. I am talking about worry or happy, the developer that is working in that class. Why the developer, the programmer, working in the class JPanel should be worried about it? Think for a moment that you are working in that class. It's not a class from a library, but it's a class that some of you in your team is developing. And that someone is you. You are the responsible for the class JPanel. And you have all these lines going in. What is the meaning of that? There are 2 people inheriting from your class. There are 3 people calling methods that you have in your class. Do we understand what I am worried? 2 people doing inheritance from my class. 3 people calling methods in my class. What if I make a mistake? There are 5 people that aren't going to be complaining to me. Having a lot of lines going in to a particular class doesn't matter if they are calling to a method, creating a variable, or doing inheritance. It's something to be worried about. It. High responsibility. Exactly that, Joseph. You make the point. A value close to 0 represents a high responsibility for whoever is the developer responsible of that particular class. Good news, this JPanel is a library class. It's an API class. Usually, you're going to have a lot of lines going in to classes that come from libraries. Why? Because it's not your responsibility, responsibility of the guy that provides the library. So, again, it's worry for the one that is developing the library. If that someone is not in your team is not worried. Someone else is providing this. If it didn't work, what I am going to say to my customer is, you know what? The library that we're using, this Java Swing, the library is not working. We already report that to Oracle. Lines in. Lines out. I am doing this class. The instability is 1. Why? No one is using me. These connections going out represent that this guy, the responsible of this, is using this J label, is using this runnable, according with this diagram, no one is using that class team goals. No one. I am not worried. If I make a mistake, no one is going to complain. According with this diagram, obviously. No one is going to complain. That is great. That is the meaning of the instability metric. Instability 0, good. 1, you know this. Anyway, so that is assuming that the class is doing something. If your class is doing something and you have this value of 0, several people is using your class, you have a high responsibility, usually we call this not only the 0, but any value close to 0, the pain zone. You can understand you are the responsible of that class, you have a high responsibility, a lot of people can complain with you, you are in the pain zone. Anything that you do bad, there are going to be consequences. If you are in the opposite here, you're fine. In fact, if you keep in this line, I am going to talk about the second dimension, but usually close to that line, you are happy. No one is going to complain. No. You're going to keep things safe. Anyway, instability, the second dimension, abstraction. Abstraction. Again, two values, 0, 1. Let me be clear. If you have a class, and that class is a normal, trivial, common class, your abstraction is 0. Makes sense, right? If you have an interface or an abstract class, for interfaces or abstract classes, your abstraction is 1. Abstract class, interface, an interface is an abstract class, right? So those two, the metric abstraction is 1. For the normal trivial classes, 0. What happens if you have a package? If you have a package, you have several classes inside of your package. You have a listener, any listener. You have JFrame. You have your class main. And, you know, inheritance, implementation. You can use the metrics for the classes. You can calculate abstraction for JFrame. And obviously 0 is a normal class. Abstraction for the listener, whatever listener you are using, and obviously is 1, is an interface. You can calculate abstraction for your class main, and obviously 0 is a normal class. You're inheriting for frame. So you can calculate this for the classes, or you can also calculate this for your package, whatever is the name for the package. If you calculate for the package, then what do you think is going to be the abstraction of the package? It's not going to be just 1 or 0. It's going to be a value between 1 and 0, which is going to be the value here. Well, I can tell you the value. Can you tell me how do I calculate that value? And hopefully it's clear that it's like, well, you have one class that is abstract, but you have a total of 3. So 1 of 3 in abstraction. You have one interface and a total of 3 elements there. Or if you want to think about, you have one that is abstract and you have the addition of the number of abstract plus the ones that are not abstract, the total. The abstraction for the package is 0.33. Or if you are talking about classes, is 1 or 0. Okay. If you have a class like this one, the JPanel, that the abstraction is 0, it's a class that have source code, and the instability is 0, you are in the pain zone. But you know what? If you put the abstraction level above, like 1, this is a happy place. Happy place. Yeah, think about, I have action listener. Or you have this interface drawable. And you could have several things, several classes implementing that. Everything go in for the interface. Everything go in, which basically means that if you calculate the instability, my out is 0. So usually for a normal class, I will be in the pain zone. But just because the abstraction for them, they are interfaces, the abstraction is 1, then I am here, not here. Can you tell me why? Why having a class with instability 0 is bad, but an interface with instability 0 is good? Exactly. Nothing is implemented yet. I can have 100 people using the interface, and the only thing that the interface is providing is a contract about the work that those people need to do. Think about the action listener. You implement action listener, the action listener, the developer of the action listener is not worried about anything. You are implementing, you have a connection going into it. Yeah, but you are the ones that are going to implement the action perform method. So if you make a mistake, it's yours, not mine. Instability low, abstraction high is good. Instability high and abstraction low is good. And that is the reason because we draw this line. Abstraction 1, instability 1 is called the useless zone. Can you guess why? Useless. Abstraction equal 1 is an interface. Instability equal 1. What that represent? You are telling me that you have an interface like drawable, right? So that guy, abstraction is 1 just because it's an interface. Now, if you have a lot of people implementing that interface, something like this, what you have is a lot of things going in, so the instability is going to be 0. And this is a happy phase. But you are telling me that there is something called useless, and that useless is 1 with instability 1. Instability 1, well, if I have this interface, drawable, in order to have instability 1, basically that will represent that I have connections. I am inheriting from something, or I am kind of having a variable from something, or I am calling a method in something, which is not possible, but use options. This cannot happen. This cannot happen. Static maybe. Inheritance, well, inheritance can happen. Why all this? It called it useless. What if you have this interface with a lot of arrows going out, but in my example, there are no arrows going in? What is the meaning of that in any class diagram? It is possible that you have an interface and no lines go in? Exactly, Jason. Can you agree with me that if you saw in a diagram an interface with 0 lines going in for a variable or for implementing or something, no one is using that class? And if no one is using that class, you can delete that and nothing is going to happen. And that is exactly the concept of useless. No one is using that. Again, we are not talking about association, composition, realization, inheritance. The only thing that we figure out is lines going in, lines going out. And with that, we calculate some numbers. And with those numbers, we figure out if we have something to be worried about it, something that is not being used, or we are good. Obviously, if you work with your project, if you take your classes, you can position your classes maybe here, or maybe one of them is going to be here, or maybe another one is going to be close to this one. Because remember, so far we are working with zeros and ones. We are going to do this with packages, and with packages we are going to have numbers that are not exclusive 0 or 1, but something in the middle. And what you're going to have is the possibility of position one package, each of your packages or your classes, in one point in this two-dimensional space. And that is going to give you an idea where your project is. Painful, good, useless, code that no one is using. Yes, abstract classes or interfaces, they are going to count like abstraction 1. Yeah, abstract classes are going to be this 1. So we do not differentiate between interfaces and abstract classes. So 1. Good. So clear. Instability, abstraction. I showed you example with classes, but this is more useful, better with packages. We're talking about big projects. Any questions so far? Good. So 2 things. Homework. Number 1, you have a quiz. Please do not forget. It's going to open by the end of the lecture, so in a couple of minutes, and you have until midnight. The quiz is all about patterns and class diagrams. So there are going to be questions about design patterns, architectural patterns, and there are going to be questions in which I show you a source code, and I am going to ask you to select the class diagram that corresponds to that source code. So it could be a good idea to review composition, association, and aggregation. It's going to be there. That is your quiz today. Second, you're working in a project. Your project is due next Wednesday, so hopefully everything is moving forward with that. And please, review the metrics, lines of code, cyclomatic complexity is something that you already know, but if for any reason you didn't review that before or you don't remember, review that in the slides that I shared with you, the source code. Practice. If you have any questions, let me know. And finally, take a look to instability and abstraction. We're going to continue talking about those next lecture. And remember, next week is your final exam. I am going to try to do a full review next week, Monday, so in a week. And then you're going to have the final Wednesday. Good? Any question, guys? Okay, I am going to stop here. See you next lecture. Thank you.